So looking at number 4, so they tell us that u sub 1 is 0.75 and u sub n is negative 2 times u to the n minus 1. So let's think about this u sub n minus 1 before we get started. If this is u sub n and this is u sub n minus 1, that means this has to be the term before. So this right here just means your previous term. So we're working with a recursive formula. Okay, recursive means it depends on the previous term, which we have the previous term. And they want us to find the first 5 terms. So we already have the first term. So to get the second term, u sub 2, it's going to be negative 2 times the previous term. Well, the previous term was 0.75. So that'll give us negative 1.5. So to get the third term, it's negative 2 times the previous term. Well, the previous term is negative 1.5. So that'll give us a positive 3. So then to get the fourth term, it's negative 2 times the previous term. Well, the previous term is 3. So that'll give us negative 6. And then for u sub 5, it's negative 2 times the previous term, which was negative 6. So that'll give us a positive 12. So my first 5 terms of my sequence I have 0.75, negative 1.5, 3, negative 6, 12. And that would keep going on forever, but that's the only terms they asked me to find. So, just to recap, explicit formula. If I ask you to find the 100th term, you can just plug in 100 and find it. If we were given a recursive formula and asked you to find the 100th term, you would have to know the 99th term, the previous term, in order to get that 100th term, okay? So that kind of explains a big difference on what it is. So we just have some 2 more practice problems of this, and then we'll switch gears a little bit. So for number 5, it says find the next 4 terms of the sequence given by the recursive formula. So recursive depends on the previous term. A sub 1 is negative 2, A sub 2 is 5, and A sub n plus 1 equals A sub n times A sub n minus 1. Ooh, a little bit tricky here. Okay, if you notice they didn't give us just 1 term, they gave us 2 terms. So that probably has something to do with the problem. Probably not just giving us 2 terms for no reason. So this is A sub n plus 1. Well, if this is A sub n, that means A sub n is the term, the previous term right before A sub n plus 1. So this would be the previous term. Well then now, what in the world does A sub n minus 1 mean? Well, A sub n minus 1 would be the previous term of the previous term. So maybe we could say the previous term. So 2 before that term. Okay? So sometimes they throw this in. I mean, I could even say times A sub n minus 2, and that would be the previous term, which would mean you'd have to be given 3 initial values. So it wants us to find the next 4 terms. So the first 2 don't really count as our terms there. Okay, so, but I'm going to write this out. So we have A sub 1 equals negative 2. A sub 2 equals 5. Okay, so if I want to find A sub 3, I am going to write this out with formula. So if this is A sub 3, the one before that would have been A sub 2, times the one that's before that would be A sub 1. Well, we know A sub 2 is 5. That's the previous term. We know A sub 1 is the previous term, which is negative 2. So that will give us negative 10. Okay? So when I do the 4th term, you're really just multiplying my previous term, which is negative 10, times the previous term before that, which is 5, which will give us negative 50. So then if we want to find the 5th term, the previous term before that was negative 50, and the term even before that was negative 10. That'll give us a positive 500. And then that's 1, 2, 3. We've got to find one more. So the previous term was 500 times the term before that was negative 50. which will give us negative 25,000. Alright, so it asks us to find the next four terms. So if we want to write it out, we started out with negative 2, 5, then it's negative 10, negative 50, 500, negative 25,000. And this will keep going on forever. So those are technically my first 6 terms of my recursive sequence. So recursive formula means that it depends on the previous term, but it could mean it depends on multiple previous terms. So you just have to pay attention. Alright, so looking at number 6. So for 6, we want to find the first 5 terms of the infinite sequence, so it just means it keeps going on forever, defined explicitly by the rule a sub n equals negative 1 to the n times 3n. A couple things here. Now, they told you it was explicit, but even if they didn't tell you it was explicit, it doesn't have anywhere in here where it has the n plus 1 or n minus 1. Also, they didn't give you a term, so you know it can't depend on a previous term. Okay, so that's why it has to be explicit. So to get the first term, you're literally just plugging in 1 for n. So we're going to have negative 1 to the first power times 3 times 1, which will give us negative 3. And then we're going to plug in 2. That'll give us a positive 6. And then we can do a sub 3 and plug in 3. Which will give us a negative 9. Then we can plug in 4 for n. Which will give us a positive 12. And then it said to go to the first 5 terms, so a sub 5. Plug in 5. Which will give us a negative 15. So the first 5 terms of this infinite sequence, and they gave us an explicit formula, we have negative 3, positive 6, negative 9, 12, negative 15. And we'll talk about this a little bit, we talk about this a lot in calculus, but this is going to be called an alternating sequence because it's negative, positive, negative, positive, negative, and it will keep going on forever, so it alternates signs. Just a little vocabulary there. Okay, the next thing and the last thing really about specific sequence, there's a special type of sequence called the Fibonacci sequence, and maybe you've heard someone say like a Fibonacci birthday would be one of these numbers. So to get this sequence, what's happening here is it's a recursive sequence because they tell you the first 2 terms are 1, and then because this says a sub n, well, a sub n minus 1 would be the previous term, and a sub n minus 2 would be the previous term. So what you're doing here, if you have 1 plus 1 and you add those together, you get 2. If you do this 1 plus 2, you get 3. That 2 plus 3, you get 5. 3 plus 5, you get 8. 5 plus 8, you get 13. 8 plus 13, you get 21. And it just keeps going on forever. So you're really just adding 2 previous terms, just like we multiplied the 2 previous terms on example number 5. But the Fibonacci sequence is a known sequence, and you were just adding the 2 previous terms to get the next number. So there is a little video if you want to watch it on your own time about Fibonacci sequence and just see how it's used in the real world. You can take a look at that on the notes sheet. Okay, so looking at number 7, so we want to write an explicit formula for the nth term of the sequence, and we want to assume that the sequence begins with 1. So going backwards here, they're giving us the sequence, and we want to write the explicit formula. So explicit formula means that if we can plug in the term number, we can get what the answer is. We don't have to depend on the one before. So what you need to look at first is what in the world is happening in this sequence. So if you look here from 1 to 5, we are adding 4. Well, from 5 to 9, we're adding 4. 9 to 13, we're adding 4, so forth. So in our sequence here, we are adding 4. If you are adding or subtracting a number to get from one number to the next in your sequence, this is called an arithmetic sequence. Okay, arithmetic, if you are adding or subtracting, it's called arithmetic. Well, this is where that formula sheet comes in. So the formula sheet that you would be given, so this means you'd always be given this. If you look, it says arithmetic here. So if you look at the top one, that is the formula we need to use. So it says a sub n equals a sub 1 plus n minus 1 times d. That is the formula we're going to use to write our explicit formula. So, things that you need to know about this formula before we can actually use it. The a sub 1 is the first term. So in your sequence, this is what the first term is. D is called the common difference. And that's just going to be what you're going to add or subtract each time. So in other words, the common difference here would be positive 4 because we're adding 4 every time. Okay? So we're just going to fill this formula in and it makes the formula for you. So that's nice as long as you know that it's arithmetic, you know to use that formula, and then you can plug it. So a sub n equals, well, our a sub 1 is the first term. Well, the first term of my sequence is 1 here, so we're going to put 1. Plus, we're going to keep the n minus 1 because we want to have that variable n. And then the common difference, so let me label this up. So our a sub n was 1. The common difference is what you're adding or subtracting each time. So the common difference would be positive 4. Okay, so if you leave in that form, that's okay, but we can simplify it out. So we can do 1 plus, distribute this 4, and make it 4n minus 4. And then we could combine like terms, so we would have 4n minus 3. So this a sub n equals 4n minus 3 gives us that explicit formula for my sequence that we had here, my infinite sequence. Now I know this is at the bottom here, but I wanted you to be able to see, like, if you were given that formula sheet, where you would have gotten that from. So that is how, if they give you a sequence and they ask you to write an explicit formula, you can use your formula sheet.